Yeah, thanks. Really appreciate the invite, Sandy, to give this keynote. I think this is the keynote I've dreamt of for about 10 years now, and you'll see why in a second. So the title of my talk is Ready for Launch, and what you see there, that's a Falcon 9 in February with the Intuitive Missions Prime 2 was going to launch to the moon. And this is about 10 seconds before launch, obviously. So key messages of my talk today. RISC-V and space have been linked at Microchip from year one, minute one. And there's been huge strides made in the last decade with RISC-V in space. And really the key point today is that I want to make is I want people to dream big. You know, this RISC-V is everywhere. Everywhere is much bigger in space. And space matters. It's not a niche market. What we're doing here, you know, we're pioneers that are lead RISC-V to greatness, I think. And so that's my next sentence. An exciting future lies ahead for RISC-V in space. So the theme of the day is flywheels. So a flywheel is something that basically stores energy, and you just nudge it more and it just keeps that energy. Then if you get feedback loops, it goes faster and faster and faster. And we're all on this big flywheel here, which is RISC-V and the space market. And I'm going to try and illustrate that. Another thing I had to do, done a lot of keynotes. And so sprinkled in this talk, I'll show you slides from keynotes in the past. So this is one I did in 2019, and this is kind of a flywheel also. It's the feedback loop that we're experiencing here today. You know, the sources, you know, venture capital, innovation and research, education, you know, invest into the RISC-V ecosystem, and then value is derived by these various segments, including aerospace and defense, and then you get the reinvestment, and you know, it starts the flywheel there. We'll start doing this tour, this decadal tour. So I know the exact moment when I first nudged on this flywheel, and it was December 11, 2014. So we're going to call it 2015 to keep it a 10-year cycle there. And it was actually a call with a company called Brunspace, and very last minute of the call, the guy mentioned that he was Frederick Bruns. I'm using a soft core in your FPGA, and I said, well, what is that? He said something called RISC-V, and then immediately that kicked off a bunch of dreams in my head. So kind of full circle, it's kind of a cool moment. So Brunspace is a Swedish aerospace company, so really you can, if you did the heritage, you know, my pushing on the flywheel started here in Sweden. I talked to Frederick. He couldn't make it here. It would have been kind of cool if he was here. So in 2016, Microsemi, as we were then known, introduced a RISC-V soft core in our FPGAs. I work for the FPGA business unit. And so we're definitely the first company to introduce a soft core as a product in the marketplace. And since then, just talking about a flywheel, Neos 5 now. I think Microblaze is also going to RISC-V. So that's taken over the soft core business. But in 2017, we started giving hints, the real reason we took this plunge into RISC-V. So this is a talk given by Satish Oda at the RISC-V Shanghai workshop. Developing fault-tolerant systems using RISC-V soft-core processors. So in the talk, Satish talked about kind of all the things and themes you hear about today, why people are here really. So RISC-V, open source licensing, provides flexibility to optimize your processor for safety-critical systems. So he went through all the things you can do when you have control of the microarchitecture to make it safe and ready for space. So reason we got in actually, and we're able to take this plunge is we had a customer who had a ground application using a Neos processor. He wanted to fly it, and he wanted to fly it on our silicon. Well, we couldn't use Neos in our silicon. we were partners with ARM, but ARM had no interest in doing the needed work to make it radiation tolerant. And so we were kind of, our hand was forced. And so, you know, unfortunately, I'd been in there evangelizing RISC-V for a year already, so people were ready to take that plunge. So I'm going to touch on this area because I'm going to talk about it again in a second. By 2017, it was clear RISC-V was going to be take over education. So in 2017, you know, Patterson and Hennessy had their famous book, Computer Organization and Design, and then they introduced the RISC-V edition in 2017. And, you know, I use the term that RISC-V is the lingua franca of computer architecture research. If you're doing, you know, so everyone all over the world is studying computer architecture today, chances are they're using RISC-V and they can communicate, use the same software. It's very important for education and research. So, you know, it's a little bit of greatest hits here. So starting in 2019, you know, I started introducing, every one of my talks had space themes in them, even though they weren't space conferences. I love space, passionate about space. So this is one here I gave. FPGA Forum is actually, you know, one country over in Norway. So this is 2019. And so I had this slide, you know, bad day for Earth. You know, the red giant's going to get us all toasted in 7.6 billion years. So I said December 3rd, 7,590,000,000, 2019 is going to be a bad day for Earth. But not necessarily for RISC-V. You know, so we got Dave Patterson, SpaceX, ESA, NASA, and we got whatever the aliens are using for their ISA. So at some point we're going to meet, and one of those ISAs is going to win. So that RISC-V is, you know, saying is going to win that one. Also in 2019, keynote in Zurich. You know, I showed this slide. This is the edge of the troposphere. Airplanes flying overhead, tons of them flying over Zurich at the time. The edge of the solar system. So this is one of my favorite images, the New Horizons. So it's actually zooming past Pluto, looks back, takes a picture of Pluto with the sun in the back. You can see the atmosphere of Pluto on New Horizons. And the edge of the universe. At the time, this thing was the farthest known object in the universe. And so what did they all have in common? They had microchip FPGAs at the edge. So we're we're on every airplane, thousands of devices. We're on the New Horizons and also on the Hubble telescope. So as my space was woven into all my talks, and I like to think that you know, subliminal messaging, you know, doing that somehow, you know, made it reality. It was fantasy, but fantasy can become reality. So we're going to talk about some more fantasies maybe a little bit later. So now, turning the flywheel a little bit more. 2021, Krista Asanovich gave this talk. Instruction sets want to be free of gravity. So he gave this talk at the Space Computing Conference. So now he's, you know, the inventor of RISC-V is now permanently engaged with this space market. So in 2022, also, our PolarFire SoC, which is an FPGA with 5 Sci-5 RISC-V cores embedded in it, flew to the space station. So we were on an experiment in the space station for about 9 months. And so I think the project was called the ISS Intelligent Space Systems Interface. So this is a hardware interface where basically I think you had to do go from space into the space station and have reliable communications. And so this board was flying outside the space station and was with the PolarFire SoC, and we were sending packets across that interface and also receiving the packets on the other side and monitoring errors and so forth. So as I mentioned, so RISC-V on the space station, it was up there for 9 months, no failures. We've done a lot on this part to try and do things that make sense, like ECC on all the memories and so forth. I don't want to say anything else about this. Yeah, so also this is plugged into the space station network. And so our guys were actually, logging into their Linux image running on the space station. It was pretty cool. So this is big. We won what's called HPSC also in 2022. So the reason Krista gave that talk in 2021 is that all that started in 2019. End of 2019, we started getting wind that JPL was going to try and take another crack at creating this high performance space computer. So as part of NASA's ongoing commercial partnership efforts, the work will take place under $50 million firm fixed price contract, Microchip contributing significant research and development costs. So this is not NASA paying for the whole thing, and we don't care how it does. It's us with NASA saying, okay, we need to make money with this thing. Thank you, NASA. We're going to help you. But Microchip has got a lot of skin in the game here. So this is what NASA means by commercial partnerships. So the SpaceX Dragon is a primary example of that. But this is kind of a got similar level of attention and expectations at NASA. So then in 2024, we launched, from the marketing launch, not a rocket launch, HPSC at the Space Computing Conference. And so, on the upper left here is the crown jewels. It's a 8-core 64-bit RISC-V vector processor. We're using Sci5 X288 there. So that is what NASA paid for. I think for this thing, there was 3 people bidding for it. 2 were ARM, and we actually bid with both ARM and RISC-V, but RISC-V won out in the end. Other things I kind of want to point out, security actually, I think, has a RISC-V tie. You look at all the, large number, any conference you go to, a large number of the academic papers are about security. It's no different here. Security is going to matter more and more in space. And then, Andreas mentioned NVIDIA has 10 processors on GPU. They chose, one of the main reasons is security. NVIDIA very early was driving security at RISC-V, and so there's actually RISC-V is better for security than other ISAs. And then you have fault tolerance, so we're able to work with Sci5, and so I'm not going to go into the details of the architecture, but there's a lot of cool features in it that couldn't have been done without being able to work with the vendor to develop the microarchitecture that you want. All right, so we're around the circle, 2025, RISC-V to the moon. So I started that nudge, and then 10 years later, we're launching to the moon. So that's that. So this is probably T plus 10 seconds. And over here, this is mission control for our project on this thing. That's a guy named Dennis Wingo, who's been involved with NASA for a long time. He works at a company called Space Built. And so they watched the launch, and then they ran back to the hotel, and we're starting to get the data that they were from their payload. So the payload, so this was the main purpose of this, and I'll talk about it more, is companies trying to start building data centers for storage in space. And then on this thing, so this PolarFire SoC was basically writing to the storage device and recording error rates and so forth in the storage device. But it was also, they had a radiation sensor on there, and they were going to, on this cislunar path, they were going to monitor radiation through the Van Allen belt, then moon orbit, and then land on the moon, and then correlate that radiation data with error rates on the device. So they had this PolarFire SoC here, so all the temperatures and voltages were being measured. Then each of these tabs you'd click on those and you'd get detailed reports, readouts of the error rates. Unfortunately, I think people probably know the story of this thing. This was going to work as soon as it landed 4 feet down, but it landed 2 feet down. So didn't get all the data that we were hoping to. But such is life when you try and go to the moon. All right, so pretty impressive 10-year run of the flywheel. 10 years from nothing to the moon. So now I'm going to try and show the part where, I think this is really important. The space market is going to be a big, important driver. So I was looking for, material to help me make that point, and wow, look at someone actually created a space industry flywheel. Flywheels everywhere. This is a cool thing. I listed the source here, Future Blind. So, flywheel, economies of scale, demand elasticity, new applications, improvement, all these things cycling back and forth to create, virtuous cycles to make this flywheel spin faster and faster and faster. So kind of the engine here is cheaper and easier launches. So this is what's changed from 10 years ago. And he plotted kind of the cost of, per kilogram, dollar per kilogram to get to orbit. And, we were kind of stuck in this 10K range. And then, in the last several years, and obviously SpaceX had a big part of this, bringing launch costs way down to, $200 with Starship. So, I think people obviously have heard of Starship, but I kind of like to show people how big it is. I mean, that looks like a rocket, but everyone's very familiar with the airplane of 747. So there's 747 right next to the Starship. So it's much bigger than 747, and the whole second stage probably has more volume in it than a 747, and of course completely reusable. I did some math here. Columbus, I think, was about $20 per kilogram to get the United States. So we're 10x away from Columbus. But then if you actually compare it to the per capita or the GDP at the time, and we're actually right now at 200. We're much lower as a percentage of GDP to get to orbit than it was for Columbus to get to the New World. So you got this flywheel, lower launch costs, and I said mix in some lunatics. So this is Dennis tweeting. This is that I did a screen grab of that's his our lunar payload on the way, and then the guys responded, "Congrats, Dennis," and Dennis said, "Lunatics unite." And there's more than one lunatic involved in this project. This introducing Chris Stott. He's the CEO and founder of Lone Star Data Holdings. His wife is Nicole Stott. She's been astronaut, has been to ISS 4 times. But this guy is truly a lunatic. Lone Star is working to save all of our data on the moon. And the line I really love is, a place so ideal for data storage that if it wasn't there, we'd have to build it. So it's not the Death Star, it's the storage star that we would have needed, but the moon's already there. So that's good. They got all these cool graphics, but they're doing the math and saying, obviously the remote is good for remote data storage, but the cooling is can be taken advantage of, is free, and the power, solar power, is so a lot of reasons to put data in space. So maybe they're not lunatics after all. So you can find this MIT. Should we be moving data centers to space? And just search for data centers in space, and you get Europe wants to deploy data centers into space. Study says knowledge beyond our planet, space-based data centers. So there's people are talking about it. When the conversation happens, things will happen, especially if the conversation keeps happening, gets strengthened. And so I'm just saying, watch out for it. You might not believe that this is going to happen, but you'll see signs, and I think you're going to see increasingly more signs. So, as I was wandering through Austin Airport a couple months ago, Dell ran this big ad powering lunar missions. So big companies want to be associated with space. Space is cool. They want to. Everyone wants to explore it. So if you want it, human beings somehow have a way of making it happen. So what about the next spin around the flywheel? So I've shown you that we are on a flywheel now. I'm trying, what's going to happen next. So for our point of view, we're doing the chip, but we're going to be building out, everyone in RISC-V wants a vertical market that's got the full stack available. And, it's going to happen first in space. And so we're going to have the hardware, the single board computers going to all be out there supporting the space market, working on all the software, operating systems, AI frameworks, development tools needed. So put this HPSC is going to be a big contributor to building the whole RISC-V ecosystem out to make it, really ready for everyone else. So space, I think, is leading in that regard. So then, you can see lots of new applications in space. I had that 10-year circle. NASA has something called the report. I think it's a decadal report, and they project what do they want to work on in the next 10 years. Every 10 years, they make this thing. So that's a kind of a flywheel we could sync to. So there's a lot of applications they have in mind for HPSC. But then it's going to be also a big player, I think, in the commercial space market as well. It's going to enable people to get their payloads up and working in space. And then, like I said, NASA just put in 50 million, but we have, there's a lot of synergy with what space needs and what other markets like automotive, defense, aviation needs. So we're going to be taking this technology that NASA helped us with, but definitely make it proliferate into these other markets. That's going to be the PIC64HX. So, circling back to the education. So, this is from the Space Foundation report. The whole section on growing the space workforce, and they're showing, good trends. Georgia Tech enrollment up over 50%. But we're going from teaching computing with RISC-V. So Notre Dame just moved from 2022, I think 2023, started teaching their architecture course in RISC-V, the lingua franca at Notre Dame. But we're going to go from teaching a lift from just teaching computing, but to teaching space computing, and they're going to be using HPSC. So, computing and spaceflight, inspiring, training next generation of IC design professionals. So, collaborate with NASA, integrating HPC design principles into computing spaceflight course. So, that's the next. We're taking around from teaching RISC-V to teaching the domain. So, to wrap up, in 2015, I became RISC-V aware, but I was hitting Brune Space's or Brune's website. And I love what they say. Courage is what speaks to me. Courage is what makes Brune who we are. By challenging your preconceived views of technology, we help you transform into something more than you expected. So I want everyone here to have huge expectations, and then in 10 years, we're going to exceed those expectations. So, back to flywheels, Intel and the PC business, that was a flywheel, 286, 386, 486, Pentium, and 1G, 2G, 3G, 4G, 5G, that was the ARM flywheel. And so why not? Why can't this be the RISC-V flywheel? So finally, lunatics and really big flywheels. This seems lunatic. Become the industry standard ISA for all computing devices, but I think Krista thought small. We're going to become the galactic standard ISA for all computing devices, and there's a really big flywheel. Yeah, so all right, thank you.